Welcome back, everybody, to Technical Talks. I'm your host, Bill Murphy. Thanks for joining us. I'm happy to represent the Hale Holdings family of companies. I'm in Quick Supply's office in Des Moines, Iowa today, and I'm often in the ASP Enterprises, Bowman Construction Supply, and sometimes even the Cascade Geosynthetics offices. We're blessed with a lot of technical sales professionals, and we have a tremendous number of clients and projects that are hard to keep up on. Speaking of keeping up, we're going to be updating our websites. Stay tuned for that. That'll be coming soon. You can see the map of all the locations that we serve and beyond. These are just where we're at, where we live, and where we work and play every day. And we do have a variety of solutions available. If you're not familiar with us, contact your local rep. We can bring you a product line card. We'd love to do lunch and learns. We love to come visit you. And we're very proud of our hard workers inside the offices and in the warehouses and out there in the trucks, making it happen for you. And I'm going pretty quick with this introduction. I want to have some time for my friend. He's been, speaking of Clean and Green, he's been to Clean and Green with us before. My next slide is going to be to introduce him, and I'm going to stop sharing my screen, and I'm going to hand it over controls. As I do that, I want to talk about safety. One of our core values at our company is safety, and keeping this guy safe was important. I'm joined by Bryan Wedin from Presto Geosystems. He was going to fly to Iowa Monday of this week. Let me stop sharing, Bryan. And he was going to fly to Iowa Monday this week, but the snowstorms across the country had some flight delays, and it just wasn't worth the hassle to travel. So let's keep him safe. He's at home in his office in Wisconsin. And with that, Bryan, let's see if we can hear you. We can see you.
You should be able to hear me.
Yeah, you sound great.
All right. I'm going to be turning off my video when we start here because it locks my computer up. So I'm going to shut that off right now.
But we don't want that. Go ahead and tell us who you are.
Okay. All right. You still hear me, Bill?
Yes, sir.
All righty. All right. Let's get started then. All right. A little bit about myself. My name is Bryan Wedin. I'm the chief engineer at Presto. Been with Presto a little over 18 years now. Before that, I was an engineering consultant, doing a bunch of different geotechnical tasks in civil engineering. I'm an active member of a bunch of different committees. I'm on the AREMA committee, which is the railroad 1 in 5 committees, roadway and ballast and track. Also on ASTM, you can see a couple here, D18, which is soil and rock, and then D35, which is a geosynthetic committee. Also part of the International ISO committee, 221 on geosynthetics. So I guess as we go through the presentation today, I'll talk about, I guess, from 2 different viewpoints. One is my 18 years as a manufacturer with Presto now, and then 18 years as working as a consultant. So today, I guess what are we going to get out of this presentation today? We'll begin by exploring the benefits of, using our rigid porous pavements. They're very, very durable system that can, work under different traffic loadings. We'll discuss the difference between the two. We have an aggregate surface called GeoPave and a vegetated called GeoBlock, and the reasons you might choose one over the other. Finally, we'll cover, how porous pavements can detain stormwater runoff, contribute to achieving those green building goals that everyone has. As Bill mentioned, if you have any questions, just put them in the question bar and we can get to them at the end of the presentation. So a little bit about Presto Geosystems. We operate in a couple different categories. We offer our GeoWeb, geocells for soil stabilization. We can do load support, slopes, channels, retaining walls. Our focus today will be on porous pavements, our vegetated GeoBlock, and our aggregate GeoPave. And we also make some construction mats. So we're also pretty lucky to have, I think, one of the best distribution networks around the whole world. We do operate globally. ASP is, one of our finest. They cover a lot of states for us. So, boy, Bill, we've had a relationship for a long time. So very good relationship. So, and ASP is not only just knowledgeable in our products, like the porous pavements we're going to talk about today, but very knowledgeable in other geosynthetics, which will be part of the presentation today also. So the first question is, why are porous pavements necessary? Why do we want to use porous pavements? Porous pavements offer a pretty cost-effective solution to meet all regulatory requirements. 40 years ago, the big buzzword was the Clean Water Act when it came into prominence, and that was the need for stormwater management. Both quantity and quality, pretty much remains crucial as part of that Water Act. Most states, I think almost everyone that I'm aware of, has established, non-point pollution regulations, with associated targets. Even local regulations even have stricter standards. We work across the United States and like I said, the world. So we see a lot of local municipalities have very strict stormwater requirements. So we can, if you have any questions on that, please answer at the end of the presentation today. So, another compelling reason to choose a porous pavement system. What is the best option for your project and your location? Many locations, really dictates the soil conditions. Land is at a premium now, so porous pavements are becoming more and more of an option to allow you to treat and actually infiltrate water at the source so it doesn't run off. We're also going to talk about some different types of porous pavements and solutions that go along with each other as you go along with the presentation. So, clearly addressing these issues is pretty critical. And finding a better way forward is pretty essential. So, at Presto, like I said, we offer those two different types of porous pavements. We offer the GeoBlock and the GeoPave. You can see here the GeoBlock, it comes in two actual depths. It comes in a 1.2 inch depth and it comes in a 2-inch depth. And we talk about GeoBlock as a vegetated paver. That's only its intent. And I'll talk about why you only want to use this for vegetated pavements. We have aggregate, which is called GeoPave. What really sets this apart is it has a monolithic mesh bottom. You can see here, if you look closely at the slides, that monolithic mesh bottom actually prevents that aggregate from getting pushed underneath the panels and actually lifting them up. A little bit of history on GeoBlock and Pave, which I'll get into. All the porous pavements started as GeoBlock. And over time, we dealt with some issues and we actually came up with the GeoPave. So I'll show that to you in a little bit here. So the GeoBlock, it's a very rigid system. It's designed to resist any kind of, bending or twisting, any kind of torsional, tire loadings. It's extremely strong. Crush strengths are, it's going to exceed, 500 PSI unfilled. So more than anything that you're going to see out there in the marketplace today. A key feature to the GeoBlock is it has an open bottom or a partially open bottom here. And the reason for that is it allows the root growth to actually go through and penetrate into the subgrade. I'll show you in a couple slides here when I talk about GeoBlock, how we have an engineered base, which is a 2/3 aggregate, 1/3 topsoil base. So basically we want that root penetration to go underneath these units. So it is only intended for occasional traffic. Since it's vegetated, you don't want to be using it on a day-to-day traffic pattern. So the GeoPave system, that pretty much advanced out of the GeoBlock. And the reason, like I said, was when we had porous pavements where we had aggregate filled into it, the aggregate would get pushed under and lift up the panels. So we reinvented the GeoPave. We added this monolithic mesh bottom. We'll specify what type of infill goes into it so it doesn't go through these openings. Pretty much you're going to get a very high infiltration rate with the GeoPave system. The pavements or the GeoPave units themselves do not slow down the percolation rate at all. It's all based on what you fill it with. So, basically we're trying to limit the fines for the GeoPave to basically maximize the amount of percolation or infiltration we get through the system. I'll also show you a couple case studies. The cool thing about the GeoPave is you can fill it with different types of aggregate. A lot of architects, a lot of engineers like to use colored infill for it. So it can be used sort of as an aesthetic installation too. So I know the BABA Act, if you're familiar with the Build America, Buy American, under the Bipartisan Infrastructure Act that recently was passed, all of our materials that we manufacture are made 100% in the United States from resins and recycled resins that are produced domestically. So if there's any concerns on a BABA requirement certification, we meet all those requirements and we can provide certifications not only for the materials, but also for the resin. So a little bit about history. Porous pavements don't have a long, probably about a 30-year life. We basically invented porous pavements back in the mid 1980s with the geocells that I talked about before. We invented those for the Army Corps of Engineers. So we have a really good relationship with them. They were having problems at the White House, the Capitol building, and some other areas in Washington, D.C., where they would bring the cars up onto the grass. It was leading to a lot of rutting, a lot of maintenance. So they basically approached us to have some type of solution that they wouldn't have to lead to maintenance. So we basically came up with the geoblock system. Once again, it didn't have the mesh bottom. It's only used for topsoil infill. So a lot of this area around the White House, the Capitol building, is basically for access, whether that's emergency access, for fire trucks, police, fire, whatever, anything that has to access the White House or the Capitol building, it has geoblock around it. And it's been in place since 1985. So, based off that success, they actually put it in the National Mall. So if you've ever been out to the National Mall, we put this in the 90s. So all these access lanes here, you can see, basically, they're basically, separated, so you shouldn't be accessing, but all these are basically fire lanes and emergency access lanes for emergency vehicles. So we've been around for, doing this for over since 1985, so 45 years. So we have a lot of experience, a lot of case studies. So get right into the porous pavements. Like I said, we have two different systems. We have the geoblock, which is the vegetated, and the geopave, which is the aggregate system. Some of the advantages of the porous pavement systems, the geoblock and the geopave, offer significant stormwater storage, within their cross sections. It allows the water to infiltrate, into the groundwater. This process really does eliminate, minimize surface runoff. So, reduce the risk of flooding in and around the pavement structure. Vegetated porous pavements, like our geoblock, really help keep that topsoil loose. So basically, when you're looking at a geoblock system, you're actually driving on top of the cell itself. You're not driving on the grass or on the topsoil. So it's really preventing that compaction. So you're going to be getting a lot of infiltration through that system.
Brian, I'm glad you're showing that screen, that slide in this one too, because I meant to say that at the beginning that was part of our heading for this, was reducing stormwater infrastructure, and we were trying to reduce runoff. And like you said all along, that's the best thing we could do, is the first thing we can do. So thank you.
Yeah, not a problem. So, this is our geopave system. You can see, and I'll talk about a bunch of case studies here, but, the main intent of this is we're going to get a lot of infiltration for an aggregate system. It's going to quickly capture that water that's going across the site. It's going to retain it on site. We can actually help you as part of the project to design the amount of aggregate you need under it for storage. So if you tell us that you need to store X amount of gallons of water, based on, the loads that we have, we can actually help you design that. And all the designs that we do are free of charge. So we'll give you calculations, written summaries, everything that you understand the system. So if you have any, pour pavements, we do a lot of porous pavements down in Texas. It's a lot of clay subgrades. So we can assist you once again if you have any water collection that's needed underneath, geoblock or the geopave systems, whether you're on aggregate. Fill trench, what kind of geotextile you should use to prevent clogging, to make sure that your drainage water goes from the surface into those drainage pipes, and the silts and the fines from the clays don't clog those drainage pipes. So we'll help you with that. We'll work with ASP, to provide the best type of geotextile for those installations. So, porous pavements, the one good thing about it is the majority of the municipalities, even the states now, allow stormwater credits. So, you're looking at reducing the size of your stormwater ponds, or potentially even eliminating them. There's a lot of projects that we've done over the last 40 years where we've been allowed to completely eliminate the amount of the stormwater ponds because we provide enough on-site storage. So once again, we'll work with you on that and help you determine, how big of a reduction in your stormwater pond that may be needed based on your infiltration requirements. So, both of our vegetated systems, our geoblock and our aggregate systems, extremely high crush strength. They're a rigid system. Looking at a significant, 500 plus PSI crush strength without infill in it. We don't need any type of sands or fillers to achieve compaction. It's, basically everything you do, you're riding on the unit itself. So whenever you're riding on our porous pavements, you're riding on the upper walls of these porous pavements. So you're not actually riding on the infill itself. The infill is just basically to fill the cells, whether it's, topsoil for grass or the aggregate for the geopave gravel porous pavers. And the one thing you got to keep in mind is whenever you're accessing porous pavement units, when it's aggregate, if you're riding on the aggregate itself, you're going to break down that aggregate over time. So you're going to break down that nice aggregate that you have into fines. It's going to lead to clogging quicker that pavement system, that porous pavement system. So you want to make sure that if you look at any kind of different porous pavement systems, you're actually operating on the top of the cell walls and not a combination of the infill and the cell walls. So, because we don't want that breakdown and attrition of that infill, so it's going to clog that system. So, that shared wall, all these geoblock and our geopave connect, they slide together. That provides a very, very secure connection. It's a framework that is really highly resistant to any type of movement, but really under torsional loads. Torsional loads are the biggest concern for any porous pavement system. You got to be able to handle that torsional load, whether it's from an SUV shown in this picture, or an Astro H20 delivery truck, or even semi trucks. Or fire trucks. All of our porous pavements can handle in excess of the Astro HS20, HS25, or the heavy fire truck loadings. And the same thing with semi trucks. So if you're backing up and you have torsional loads, especially when they're not moving, you got to make sure that those porous pavements have that rigid cell wall, so they don't actually rip the cell walls, which we see on a pretty common basis with their porous pavements. Another one, another advantage here is that due to those extremely rigid cell walls, you can actually access all of our porous pavements, the geoblock and the geopave, unfilled. So it's very easy to install them and to fill it. We do recommend, if you're going to be using any type of tracked vehicles, that it doesn't have the big shoes on it, just so you don't score up the top of the panels, or as tired as you can see here. But you don't have any type of, like I said, since the infill material isn't providing support, it's just providing the infiltration medium. You can actually access it when the panels aren't full. So that's really going to cut down on the amount of installation time. So you don't have any special requirements to infill any of these porous pavements. So, they're really designed for low maintenance, limiting any need for any type of, ongoing maintenance. The interlocking units really do provide you that stable system. We offer a bunch of accessories that go along with our porous pavements. A lot of the traffic delineators, if you're looking at a parking site, sometimes you'll want to have traffic delineators, whether it's the handicap spots or emergency vehicles. We have different colors of delineators here. You can see a hard surface pavement here with the white lines. And I'll show you a couple of case studies where you actually can draw or paint the white lines on a system. So lots of different options for you on that also. Both the rigid and the flexible systems, very heavy loadings. Like I said, emergency access is one of our biggest applications for porous pavements. A lot of that is fire lanes. This is a project here out in Wichita, Kansas, for Newman University. They were having problems right here when they had to get their emergency vehicles across the grass surface. So they came to us, and we did a porous pavement, the geoblock porous pavement, across all these areas so they could get emergency vehicles into these sites. So the ability to use these systems really is crucial, really, to providing that extra reinforcement needed, so you don't have to provide maintenance every time so vehicles have to access this for emergency. Emergency isn't just fire. You have a lot of times where ambulance, police vehicles, or just sometimes, a lot of times when, like say at Newman University, they would have events. So they would have the maintenance vehicles or the catering vehicles drive up and across the grass. So it was becoming a maintenance nightmare. So that's why they went with the geoblock porous pavements. So another big advantage is tree root protection. We do a lot of this overseas, especially in the United Kingdom. In Australia, that's really a big tag word over there right now, and it has been for going on about 10 years, is tree root protection. If you got a lot of areas where you can't compress the tree roots, they have local ordinances where you have to make sure that you don't damage the trees, compress the roots, and kill the tree off. We can use the geoblock and the geopave for tree root protection because it provides that rigid support, but it really does dissipate the amount of stress that's reaching the subgrade. A rule of thumb when you're looking at a 2-inch geoblock or a 2-inch geopave porous pavement system, that's equal to a minimum of about 12 inches of reinforced base. So if you have a 2-inch geoblock or a 2-inch geopave system, like I said, that's about a 12-inch base. So could handle a significant load. And like I said, most of these geopave systems are going to have a small base underneath it, depending on the subgrade strength and the type of loading. So you're talking about a very really thick cross section of unbound aggregate compared to a geopave system. So So I'll get into the geoblock system. Once again, that's it's a vegetated surface. Basically it's going to blend in with your local surroundings. You want to make sure, like I said, it's a vegetated system. It's not for 100% traffic. It's for an overflow parking. Like I said, we have two different systems. We have the geoblock, which was the original, 1.2 inch depth, and we have the geoblock 5150 for a 2 inch depth. The only really difference in those two is that the 2 inch, it's a lot of plastic in a 2 inch geoblock. So on some of these low maintenance, whether it's access truck vehicle or truck access, you don't need that much support. So we came up with a geoblock to provide a more cost-effective solution for those type of applications. So most of the heavy duty fire truck, semi-truck access like that, you're going to look at the geoblock system. So a typical panel is 20 by 40 inches, about 5.3 square feet. You can see the interlocking tabs that go around the units. They just slide together. Like I said, once they're slid together, you can drive on them. Here is a typical cross section. You can see the geoblock unit. It's filled with 100% topsoil. There's no aggregate in it. It's any kind of local topsoil that's going to maintain vegetation. You're going to have a base underneath it most of the time. We call it an engineered base, and what that is a 1/3 topsoil and a 2/3 aggregate. So what you're basically doing is taking a bucket full of topsoil and mixing it with 2/3 or 2 buckets of aggregate. And the aggregate can be just locally available 2 or 3/4 inch crushed. You want to limit the fines to about 10%, at least, like I said, so you want that percolation of that water that goes through the system. So, and like I said, we'll help you with the amount of this aggregate base that's required. We do have these standard charts that are in our design manuals. You can look at whether it's a geoblock or a geoblock 5150, the 2-inch depth. Based on the subgrade CBR, it has typical engineered base depths for you based on the vehicle. So you can see if you're looking at a 2-inch geoblock 5050, typical fire truck loading on say a 3 CBR, you're looking at a 6-inch engineered aggregate base. But I would highly recommend I mean, you can use these as a starting point, but I would highly recommend reaching out to us or ASP for every single project that you do. Standard tables and charts are great, but every project is different. Every site is different. Every site has different project requirements, and whether you have 100 square feet of porous pavements or you have 1 million square feet of porous pavements, we're going to give you the same design evaluation. It's going to include a written summary, talking about the benefits, talking about your site. It's going to have calculations that are site specific. So it's going to be based on your site's or subgrade strength, the number of applications or the number of sites or times you're going to go over this geoblock system. We're going to provide some site drawings, cross sections, and we'll also help you on site. So if you have some installation concerns, or the contractor will be on site to help them install it. So there will be no questions once you go from start to finish. So we're not going to stop our assistance once it leaves the door. We'll be there all the way through construction. So, typical applications, like I said, anything that you want a vegetated surface for, for temporary parking, overflow parking, churches, stadiums. We do, a bunch of NFL stadiums. Actually, I'll show you one of the ones right in St. Louis. We do a lot of church overflow parkings, fire lanes. I mean, you name it, anything that's a temporary parking solution. So this is one that was it's actually in Missouri. It's for the Mercy Medical Campus. They needed a fire lane to access their campus, but they wanted a green space. They didn't have enough area around it to provide a stormwater pond, so they were sort of landlocked. So, they opted to approach us when we looked at different types of systems. We looked at the GeoPave, we looked at the GeoBlock, but the campus really wanted a vegetated solution. So we worked with them and worked with ASP to come up with a system. Here you can see that the majority or a lot of our GeoBlock systems may or may not have a curb or a designation where the porous pavement stops. The campus here decided that they wanted to have a hard edging, so they put down the concrete edging, and you can actually see the GeoBlock, some of it being installed in the center before it got done. Here we go, and you can see a better up close picture here. With basically all the topsoil is put into the GeoBlock. The engineering base is into place, and you basically just back scrape that. So the top is you're basically seeing the top cells, and you're driving on those top cells. We're not compacting into that top cell. So you're going to get really good vegetation growth. But like I said, the main purpose of the campus here is they wanted a vegetated surface. They didn't want an aggregate surface. They wanted something that looked nice behind their building. So once you can see here, as the grass growing, you really can't see the plastic material at all. Pretty much blends in with the surrounding areas. And like I say, you can see that concrete curb. They wanted to have that curb because they wanted to make sure if there was emergency access or temporary access, that they stayed within that one area for heavy vehicles.
Hey,
Go ahead,
Brian,
Bill.
I love that before and after. I love that you talked about how they back scrape that. You guys are the ones that taught me that you don't want to overfill these. So many other things we seem to hump it up and overfill it like a muffin, and you absolutely don't want to do that because you don't want to overcompact the material and then not be able to grow grass. So yeah, like that. It's just you guys are the ones that came up with that, and I think it's a wonderful idea not to overfill those cells.
And a lot of people think that the more you put in, the better. But
Yeah,
and actually, what happens is if it's not confined in those cells itself, it's going to overcompact. It's going to
yeah,
prevent the water. So you lose your infiltration. So that's really an important thing. That's something, Bill, that we'll work with. We'll do pre-installation meetings with the
good.
contractor, with the engineer. We talk about that. Usually these meetings last for 15 minutes, so it's not a big deal with the contractor. But when the contractor gets out to the site, he knows what's going on. And then, like I said, usually there'll be someone on site to help him with that. So,
Yeah,
but yeah,
that was great.
good question.
Thank you.
Yeah. So, like I said, when you have a vegetated system, there's really no other maintenance requirements other than just growing regular grass. You're going to fertilize it. You're going to, if it needs, you can cut it as normal. There's nothing really different than any type of normal grass surface that you have. This is one that we had at the St. Louis, the Edward Jones Dome in St. Louis. They had went with a flexible, rolled porous pavement. It failed. There's not a lot of strength to it. So they came to us. They wanted something that was more rigid because they had the failed system. You can see it driving over these. This actually system requires sand to get compaction. And it's very hard to grow, as you can imagine, grow grass in sand. So whenever it's under torsional loadings, it just rips those cells out. So we actually worked with them. We came up with the design using the Geo block. So this is the 1.2 inch depth. You can see the panels going down. We'll help you with the different types of patterns, whether it's a running bond, a staking pattern. We have different types of installation patterns that you can use. And we'll work with you, during the design phase to come up with the best one. You can see it's very easy to cut in the field. It's just plastic. Most of the time, you're just cutting with a PVC pipe saw. So, like I said, you're going to put a strike down, strike it, and cut it. So very easy to cut in the field. Here, once again, here's another close-up of the topsoil being infilled. This one actually did have a little bit of aggregate because they used a little bit extra of the engineered base here, which is fine. That's not a problem. You're still going to get good compaction. This one, they wanted to get on it right away. So they actually sodded it. You can seed it. You can put erosion control blankets on it. You can hydro seed it. This one, they wanted sod. They wanted immediate access. So like I said, they sodded, and then they run it over with basically a small compactor just to drive those roots into the geoblock unit itself. So, and here you can see the system. We took these pictures about 11 years later. You can see, like I said, overflow parking during football games, things like that. Access is still not a problem. And then we actually just took these last summer, Bill. So here's a couple more pictures of, the grass is still looking great. We took these pictures in the spring, so grass is just coming up, but you can see there's really no maintenance over the last 15 years that these have required whatsoever. So very nice installation right next to
the
this.
arch in the picture on the right, and it tells everybody it's downtown. I love it.
Yeah, it's definitely downtown next to the dome. So if you're down by the dome, and like I said, most of these porous pavement systems that you'll never see them. I'm sure everyone has either parked on them if they parked on grass next to these stadiums or churches and things like that. Or walked on them. We have porous pavements in a lot of stadiums across the country. So this was an interesting one that we did a couple years ago. This was down in Lower Michigan. This was for an Indian tribe. They have a lot of their powwows. They do a lot of outdoor activities with tribal members. They have a lot of, concerts. They have a lot of, just regular get-togethers, and they're always driving vehicles on top of the grass. They had a ton of rutting. This was a really soft clay surface, so you can imagine when it was wet, they'd get a lot of times where they have rutting here, so they'd have to go back in and and fix the ruts and do a lot of maintenance on here. So One of our presentation, we did a distributor down in Michigan. The tribe was in attendance there. And we went out, we looked at the site, came up with a design. This was actually a pretty big site. This was about 3 or 4 acres. So it was a pretty big site here. So here you can see we did a design for them. We worked with them through construction. This one did have a 2-inch engineered base on it. The subgrade was pretty strong. You can imagine, clay that when it's not wet is very strong, but when it's dry, it's really strong. When it gets wet, it loses its strength. But for here, it's just going to be smaller vehicles like trucks and things like that. So we put a 2-inch engineered base underneath it to cover those heavy equipment loads. You can see here we went with the herringbone pattern for it. So like I said, we'll work with you on all the different types of systems. So, and here you can see what it looks like once it was all vegetated. So it started like this in the fall. We got done installing this in southern Michigan, actually. It was probably, I think, mid to late October, I think, when I was down there to take some of these pictures. And these pictures were taken I think I took these in May. So once again, it really doesn't hinder the amount of vegetation that grows. It's still going to look good. You still cut it. So really good system. Here's a nice one. We do a lot of these down in Florida. Along Texas, California, when grass is going to grow like crazy, but you still got to get some access. A lot of these are sandy subgrades, so vehicle access over sand, you can imagine, those vehicles there's no confinement, so those vehicles are going to want to rut and get stuck in the sandy subgrade. So we do a lot of these, like I said, straight porous or fire lanes across these. This is a big condo development down in Florida. Outside of the villages, we have a lot of porous pavements there for fire lanes. You can see pretty much just straight access and filling it with the local available topsoil. Here you can see 100% topsoil filled in. And they actually hydro-seeded this. And this picture was taken a couple of months later, actually before they came back to do some of the erosion controls on the sides of these systems. So we can work, like I said, we'll work with you on the type of vegetation. Well, like I said, there's different ways to do it. Here's a hydro seed job. This was a smaller job, but something that we run into all the time is that homeowners, have problems accessing their yards. This one is actually for a septic drain field. Really a nice home here in the country, New Hampshire. Every time the guy had to get his septic and drain field pumped out every spring and every fall, it led to a lot of rutting on the surface. And he was just fed up with it, spending all the money. So he came to us, our local distributor. Like I said here, with since it's just a septic collar, we didn't put any base under it at all. So it's just basically spreading it out, compacting the base lightly, filling it in with topsoil, and then getting a stable surface that they could drive onto it. Like I said, we can do different types of vegetation. It can be sod. We can seed it, put a erosion control blanket over it. But really the quickest one, and I would say the one we do most now, is just hydro seeding. Just hydro seed the surface. We can work with you and ASP, the different types of tackifiers, different types of hydro seeds that are the best, for the different applications where they're located. So we can work with you on the hydro seed too. So, and here you can see this was about 2 months after completion with the hydro seed. Nice and established. This has been in service for about 2 years now. He has had no maintenance whatsoever every time that septic collar pulls onto the grass. And actually, due to the success of this small little job that we did, the septic collar has sort of got word got around town, and we've done 4 or 5 extra jobs since then for the same type of applications for septic onto people's yards. But overfill parking, is one of the main things that we sell the GeoBlock system for. Like I said, it's very flexible. We can't stress that enough. Easy to cut. There's really nothing to it. Here you can see once again a herringbone pattern with a strong concrete edge on it. Goes around these obstructions here. As you can see, here's the unfilled beforehand and vegetated afterwards. This was an overflow for a church, so a very flexible system for installation. Here's another fire lane. Here you can see this was an architect that we worked with on this project where they had to get access to all around this building here. So here you can see we put GeoBlock porous pavements in all of these grass service lanes for access to the for fire vehicles. We've also installed a GeoBlock at some pretty important historic sites around the world. I mean, this one is at Stonehenge. If you ever had the, I guess the luck of actually going to Stonehenge, we have geoblock all around Stonehenge, basically to prevent, any type of degradation. You can see a lot of these this is all geoblock on all of these sites. Here was some recent ones that we installed. This was taken about a month or so after it was installed. So, it's been installed from the White House to Stonehenge, from backyards to all different types of installations. So, like I said, we can work with you on that, on any type of vegetated porous pavement. So, talk a little bit about the aggregate system, the GeoPave. It's a fixed depth. We only have a 2-inch porous pavement. Like I said, we have those snap delineators that we can put into the geoblock system. The one big thing about that, if you get anything on this presentation, is that, the geoblock is vegetated, the GeoPave is aggregate, and that mesh bottom really sets the GeoPave system apart from any other porous pavement out there, is that it really prevents, that aggregate from getting pushed under these panels and lifting them up. And that, that's going to lead to a lot of maintenance, a lot of long-term maintenance. So, and that's why we put the mesh bottom on it. So here you can see just a typical cross section. I mean, like I said, it has a 2-inch nominal depth. We'll work with you. We do have those standard tables, which I'll show you. But like I said, I would highly recommend reaching out to us or ASP. Like I said, no matter if it's 100 or 1,000,000 square feet, we're going to give you the same type of support and make sure that that whatever system you get is going to work for your installation. A lot of times in our manuals, it'll say put down a non-woven geotextile, but like I said, if you have a high silt, base, I mean, what's going to happen is those fines are going to want to migrate up and contaminate and clog this system over time. If it's a non-woven geotextile. So we'll work with you to make sure that not only the right porous pavement, but the right geotextile separation layer. So once again, here's our standard table for the GeoPave. It'll be the different AASHTO descriptions from HS 20, 25, right down the trail use. So here you just correlate the CBR of the subgrade, and you can get a depth. But like I said, please reach out to us and we'll come up with an evaluation for you. So now I'm going some case studies. This is a project in Tennessee. This is a cell tower that we do. It was on a hill. There's a lot of stormwater runoff. They had to manage it on site. They weren't allowed to have any stormwater off site here. We do a lot of cell towers and a lot of electrical substations. And the good thing about electrical substations with GeoPave is that it provides 100% infiltration. So if you're an engineer consultant that works on electrical substations, you've probably heard of those keywords about a touch step potential. What that is if any water is ponding on the surface, you touch anything, you don't want to get electrocuted. So we do a lot of electrical substations, a lot of cell towers where that touch step potential may happen. So we want to make sure we get this water to drain right out of it. So we've done hundreds and hundreds of these type of systems all around the world, actually. So we can help you on that with the design. This was a pretty beefy one. This had a subgrade strength was a little bit less, about around the 2% subgrade CBR. So they actually went with the chart was about a 6-inch base, but we worked with them through the design, and this one ended up being about a 10-inch engineered base underneath the GeoPave. Once again, you can see an open grade aggregate. They just very light equipment. You don't need any heavy equipment to install it. Once this is all infilled, like I said, they just back drag it to make sure that the aggregate is on top of the systems. You don't really have to compact this because you don't want to break down the aggregate. Naturally, it'll just find its place. Here you can see how they connect the panels together with the GeoPave. We have these U-clips that provide a really strong connection. Once again, we're going to have that geotextile underneath it. And whether it's a non-woven or a woven will help you with that, during your design phase. But, this is about a year after the installation of this one. You can see the road's is held up pretty good. Water flow 100%. You can see how much of a slope this is. Like I said, they weren't allowed to have any flow coming from here going across their site. So this basically captures all of their overland flow and lets it percolate into the ground. So, but once again, if you have any electrical substations here, the touch step potential might be an issue. Please let us know, and we can give you an evaluation for that, so you can completely eliminate that concern. So. This is a project we did to Citadel down in South Carolina. They wanted to expand their parking sites. And the majority of the parking site expansion here was due to when they had the graduations. They weren't allowed to do any expansions on because they couldn't expand their stormwater ponds. So we do a lot of work down in South Carolina, a lot of work with the military, especially on military bases with our work with the Army Corps of Engineers. So they came to us to provide a porous pavement system along with their hard surface pavements. So we worked the engineer and the actually the Army Corps on this one. We added about 120 or 130 extra stalls, about 75,000 square feet. And we work with the conjunction with the asphalt pavers here. So you can see here, we worked with the type of geotextile we put down. And this one was a sandy subgrade, so we didn't have any concerns with fine migration. So we went with an 8-ounce non-woven here, put about a 4-inch base underneath the geopave units. This was once again, a herringbone pattern and filled with an open graded aggregate. And you can see the final parking spots. They elected here to just put in concrete bumpers for the parking. They didn't need any delineation. You can see a lot of what they did is they didn't spend a lot. The contractor didn't do a very good job of actually pulling that aggregate back. I like to show this slide because you can see after we left the site, they actually came back and back dragged this after the site. But you can see some of the aggregate was left because they didn't back drag it. So make sure that when you put these pavements in, you want to make sure you back drag that just to get so you can see the top of these cells, or you're going to have running. You can see the running right here, so you want to make sure you back drag that to remove any excess material. So this was probably the most challenging one I've ever worked on. This was for Mercedes-Benz dealership out in New York. We worked with the Army Corps. We worked with the engineering consultant, and the engineering consultant had the 100-year flood elevation given to them, which ended up being incorrect. You can see here, this was 3 acres of extra parking that we had. We did the design. You can see this was a running bond where they just ran the panels back and forth over this 3-acre site. And it was just to store, basically Mercedes-Benz cars and trucks before they got sold. So we worked the engineer. Like I said, you can do these inserts. You can do the delineators here. Since he wanted to be able to move the things around the site, you can see a bunch of Mercedes parked. He actually just painted them. It's been in service for about 3-4 years now. And he just goes out there every 3-4 years and actually just repaints the stripes. So, but the reason I wanted to bring this up is this was a challenging system. You can see the Atlantic Ocean here in the background, but the engineer was, like I said, was given the wrong 100-year flood elevation from the Army Corps. So when they did this site, when they had the big hurricane up there, 4 years ago, the water actually backed up into this porous pavement system. It was just covering the tires of this parking lot. So everyone was very concerned that we had some problems with infiltration, but we ended up deciding that it was actually the 100-year flood elevation was wrong. But as the water percolated all the way across this site within a couple hours of the rain stopping, and they got about 10 or 15 inches of rain over 24 hours, that water completely percolated and was gone. So it really does infiltrate a lot through the geopave units with the engineered aggregate and the engineered base. So another parking one, this is in California. This is a couple acres. This one was an overflow, once again, an overflow system. They wanted to control all the water. This was also on a site, on a sloped site. You can see if you look closely here, they wanted an edging here, but they just used a pressure treated lumber here. So they didn't pour a hard surface or hard edging. They just used a pressure treated lumber. So once again, it was just basically to manage their stormwater that you can see the slope. They want to keep everything that was coming here percolating, infiltrating before it got to the street down below. Once you can see here, very easy to cut. You just put the system up here. Whoop. We go back. You just put that up there and you cut it. Very easy to cut. Like I said, mostly with a PVC pipe saw. So, and then the finished system. Here's a sport complex. We do a lot of these type of systems where it's a basic integrated system with asphalt. You can see here we're using geopave for the parking stalls. This was about 75 spots they needed. Once again, they didn't have any kind of area for a stormwater pond, so they needed some type of porous pavement. They were allowed, when we did the calculations with them, we determined that we could use asphalt for the running lanes. So they used asphalt for all the running lanes, and all the parking spots. You can just see this overhead picture here. Any parking spots were all geopaved for about 75 spots. But the good thing that allowed them to expand this parking area and the sports complex because they didn't have any stormwater capacity around those areas. So a couple interesting ones we can use. We do a lot of road shoulders. This is a project out east. It's up in New Hampshire. A lot of cars were pulling off on a scenic overlook. They didn't want to have any paved surface here, so they left it basically aggregate. And every time the people would pull off and pull back on, they were running it, starting and stopping. So they actually put in the geopave system. It's not a very big installation. It was maybe 4,000 or 5,000 square feet, but it completely eliminated any type of maintenance they had for pulling off. You can see also another picture. This one is actually a stormwater trench to get water into the stormwater system here. So they have the asphalt road on the side. They didn't have enough money really to put in a lot of stormwater piping, so they used infiltration trenches and the geopave on the side. So pretty flexible system we can work with you on.
Brian, I love that one. Before you get away from that one, was there any concern about snow removal? I mean, I know New Hampshire gets snow like a lot of people.
Yeah, that's a good question. I should have brought that up a couple of slides ago. But yeah, so with any porous pavement or any type of aggregate surface for that matter, you want to make sure you have the discs, the plow discs on the plow. So you want to have those discs and keep that plow blade, half inch to an inch above the surface, because whether it's unpaved with aggregate, if you plow the surface, you're just going to pull that aggregate out. So use plow discs on it, and you'll have no issues with snow removal.
Thank you.
So yep, and like I said, all your geopave installations, you sure have a lot of them. There's a lot across the Midwest. I mean, like I said, just use the plow blades, and you should be no issues.
I have an aggregate driveway. I live out in the country, so I've got to keep, you call them plow discs, the shoes that I lower down below the blade, so I'm not getting rid of all the rock. Yeah, it's the same. So yeah, that's good.
Yep.
Thank you.
Yep. And trails. The good thing about the geopaved trails is they're ADA accessible. So you can see here, this is Rookery Bay down in the Florida Everglades. We have about 3 miles of trails that go around this site. Really, there's no base underneath this. Just put down a geotextile, fill it with aggregate, and it's a good walking trail. But they also can use it if there's ever an emergency on the trail. They can get SUVs down it or small utility vehicles. In case someone, there's been times where people have, maybe twisted an ankle. They can get an SUV down there or something to help them get off the site. So this is actually a project not far here from Wisconsin. This is up in Door County here in Wisconsin. The architect did all porous pavements around this nice nature preserve. They used aggregates or geopave filled with aggregate for the parking lot, but then there was walking trails that went all around this site, and they used different colors of aggregates to delineate what type of part in the system or the environmental center they were at. So very, very flexible. Architects get pretty creative with our geopave system. So I think I got good time. So just in summary, like I said, our system is very rigid, whether that's geoblock or geopave. Rigid cell walls, you're not really driving on the infill itself, you're driving on this rigid cell walls. Whether it's a vegetated surface with topsoil, which is the geoblock, comes in 2 different depths, 1.2 and 2 inches. The aggregate is the geopave system. Like I said, we're going to work with you on the type of aggregate that is used to infill the system, and for that base, whether it's an engineered base for the geoblock or an aggregate base for the geopave, we'll work with you on that. Like I said, they're very, very strong HS25 design loads. And when I say that, that's a full fire truck loading. So you're looking at a 20,000 pound wheel load and 110 PSI tire pressure. So, it can easily withstand any type of those loadings. We've actually installed, our geopave system in intermodal yards when they're looking at reach stackers with, wheel loads approaching, 150 to 175,000 pounds and tire pressures, exceeding 140 PSI. So, like I said, very, very strong system. You can access it, do the rigid cell walls, you can access it and use to install. As soon as we get it down, you're looking at high infiltration rates for both systems. And like I said, we'll work with you on the amount of infiltration and the potential to reduce any of those stormwater ponds or your stormwater capacity. So just like ASP, we have a really detailed website, talks about all of our products here, all our applications. We have design We have installation sections. We have a learning section where you go to our website at prestogeo.com, look at hundreds and hundreds of recorded websites or webinars that we have. Our YouTube channel has hundreds and hundreds of videos for you. If you want one of those project evaluations, just click on that project evaluation. It'll walk you right through it. You select your GeoBlock or your GeoPave. It comes to myself and our engineering team, and within usually a day, 2 days max, we're going to get back to you with a full evaluation. And if we have any questions, we'll make sure we reach out to you, right away to make sure that we're all on the same page for the evaluation. So, and like I said, we have those standard tables. They're great to reference, and I recommend that you use them, but I highly recommend you reach out to ASP or to Presto. Like I said, it doesn't matter how small or how big it is, we're going to give you the same service. They're free of charge. We want to make sure that, we don't misapply a geotextile that could actually, hinder the success of the installation. So reach out to us. Like I said, in a day or two, we'll get back to you. With free project evaluations here, you can just see what this is actually for a GeoPave. It's going to have the full calculation. We'll walk you through it. It's going to have you a little cross section here showing the 2-inch GeoPave depth and the amount of aggregate base needed. And based on the type of loading, this is an HS20. So that's an 80,000 pound vehicle, 16,000 pound tire loading with 110 PSI. So like I said, we'll have all those calculations in there for you. And the written summary, specifications, all that is free of charge. So when I talk about CBR subgrades, I have this form. I've been using this when I was a consultant. I've been using this for almost 40 years. A lot of times when we have projects, you don't have the amount of money to do a full geotechnical report, especially for these smaller projects. So I'll get a call from a consultant or one of our distributors say, hey, I got this site. I need to use a porous pavement, and I don't know how. And I'll ask them, well, what's the subgrade like? I have no idea. So I have this laminated. If anyone's interested in this, I highly recommend carrying it in a book bag. I've given out thousands of these laminated identification charts. So if you call me up and I say, what's the site look like? And you say, well, I'm walking across it and I sink an inch. So I go to this graph right here, this part of this chart. So a man sinks an inch. From there, I can correlate that to a CBR and provide you a full evaluation. So if you call me up and say, I got a site that I have a blow count of about 8. So I can correlate that once again over to a CBR. So all these different things. So rather than having to do a full geotechnical report, like I said, you can just call me up or call ESP up and say, I got my dump truck ruts an inch. Once again, here's a very subgrade. We can correlate it to a CBR and provide you the evaluation. So like I said, if you're interested in that, reach out to myself. You reach out to Bill. Here is my contact information, my phone number, and my email. If you want one of those, like I said, reach out to myself or to Bill, and we can help you out on that. So with that, thanks again for your time. I appreciate it. And I guess Bill, you wanna bring her home?
I want everybody to know we've already scheduled our next webinar. This one here is going to be, if you can grab your camera, folks who are watching at home, you can take a picture of this and get on that QR code. That'll link you to our next webinar in January. It's going to be a joint presentation with Ben Campbell from Solmax and Tyler Searle from Muscle Wall. We've got a lot of opportunities for levees. Similar to what Brian was talking about, we're getting a lot of rain, a lot of stormwater. We're trying to reduce flooding. Sometimes flooding is inevitable, so we have to have levees across the country. A lot of them need repaired and raised. So we're going to cover that Wednesday, January 8th. Click on that to register. Next slide, please. Sorry to do that to you, Brian. Excited. Brian's been a part of it. He and I got to spend some time together earlier this year. Clean and Green's coming back in 2025. You can see the dates there. 4 dates in February, 2 in March. That QR code on the screen is not the same as the previous QR code for the Technical Talks webinar series. That QR code right there is what'll get you registered for Clean and Green. Please do that so we know how many people we're feeding. Portland, Fort Collins, Omaha, Des Moines, Kansas City, and St. Louis. I will be at all of them. I'll be your MC. And you could leave that on the screen here, Brian. I'm going to go say Madison Gibbler. Yeah, sorry, Maddie. Yeah, all participants are muted. Sorry I didn't get to that earlier. I'm just now getting to the Q&A. Yeah, as a webinar, everybody's muted. Question for you, Brian. Oh, here, yeah. Let's say I'm going to go to Maddie since she was first one in. What are the infiltration rates? And you already said that the cell doesn't limit it. It's all based on the infill. And how do you measure infiltration rates for, let's say, an aggregate system?
There's all kinds of references that we use. There's research and testing hundreds of universities, across the nation on different types of infiltration rates. There's government accepted rates, and we usually refer to those. I know the University of Central Florida is probably one of the biggest ones that really and looks at porous pavements and infiltration rates in different types. But New Hampshire is also another big one. So we'll work with the engineer and the consultant, basically on different types of infiltration rates based on the type of subgrade that you have. So all based on different types of testing.
Thank you for that. She might even be talking about out in the field if you go out there and just try to physically measure it yourself. She and I have done some permeable paver systems where we've gone out and tested it with that infiltrometer test. So,
yep. And that's the same thing. Like I said, there's accepted methods.
Yep.
For all porous pavements that we recommend and use. So yeah, we'll work with you on that and send you, types and examples of how to test it. So
she's a good friend from Kansas City, Burns and Mac. She's also asking, how do you repair and replace geoblock if you need to access subsurface utilities? Particular, she asked about the medical campus. Was there storm sewer adjacent to it or underneath of it? And I think you got into that a little later. But if somebody does have to open up a system, how do you recommend they get into it and repair it?
I'm actually just with a PVC pipe saw. You just cut it. Since it's at the surface, you just cut the panels, cut them out, and then you can actually put them right back in. So just basically cut them out, pull them up, install whatever you got to install underneath it, compact it, and then put the panels right back in.
That's awesome. Well, we got so many questions. I tell you what we're going to do. We're going to have these in writing. Yeah, there you go. Thanks, Madison. We're going to have all these questions in writing, and Brian's going to help me. We're going to answer all of these. So when we send out the information here at the end, we'll have all the questions here that we're going to capture, and I'm going to make sure that I get all those. We'll have Brian help type out answers to each of those. Also, in the survey, if you didn't ask a question today and you want to, please do that whenever you return the survey to Madeline Kreitler, our Madeline. And we'll also have the opportunity for Brian to give that card that he says he laminates for CBR or anything else he wants to attach as a PDF. So all attendees will get that along with their PDH certificate. So with that, Brian, thank you for joining me. Everybody, the views and opinions of the host are not necessarily those of Hale Holdings family of companies, but I say from my family to your family, Merry Christmas. That's for me personally. Brian, I appreciate you, and we'll talk real soon about getting all these questions answered.
All right, thanks, and thanks for attending, everybody.
Thanks. Take care, everybody.